Okay, today we're going to be doing the same thing we did the other 2 days. Just going to make sure you have a good handle on that. So, on each question, you need to answer 3 questions. You need to state how many possible positive and negative roots there are. State all possible roots that you could have. And then find all the roots of the function for each of these functions. So here's the first 5 you're going to do. Write those down. You can pause the video right now to do that. Here's the next 5 you're going to do. Pause the video right now. Write those down. And that's what you're going to do today. I'm going to work through the last 2 with you to show you what I want for each one of these, and then you can do the other 8. Okay, so let me work through number 10 with you. So the first part says, tell me how many possible positive and negative roots there are. If you notice, that's what it's saying. State how many possible positive and negative roots there are. So that's what I want to do first. To do that, we use Descartes' rule of signs. So I'm just looking at whether they're positive or negative in f of x and how many times the sign changes when it's in descending order, which obviously it's already written in descending order. X to the 4th is first. So I'm just saying we have a positive and a positive. Did the sign change? No. I'm going from positive to negative. Did the sign change? Yes. There's one sign change so far. I'm going from negative to negative. Did the sign change? No. I'm going from negative to positive. Did the sign change? Yes. All right, so that tells me I have 2 possible positive roots. Or 0, because remember they can decrease by 2. I will tell you this, all of them are going to come out without any imaginary numbers. So none of these will have imaginary values. Okay, so therefore it's going to have the 2 possible positive roots. Now how do I do the negative roots? Well, I want to do f of negative x. So if I think about that, I'm going to do f of negative x out here to the side. That means I'm going to replace every x with a negative x. Now remember, the even ones don't change, so that's going to stay positive. When you put in a negative x there, a negative times a negative times a negative times a negative is going to remain positive. The odds will change. So instead of positive, this next one will be negative. The even will remain the same, negative. The odd will change, positive. That one's an even. The constant doesn't change on either one, so therefore that's positive. So how many times does the sign change? 1, 0, 1, 0. So it changed twice. So there's 2 possible positive roots, or 0. There's also 2 possible negative roots, or 0. So this is the answer to part A. Now that tells me something. When I go to try them, there's probably going to be 2 positive and 2 negative, so that doesn't really tell me that I can eliminate hardly anything that I can try. So that's what I'm going to start with, is I know there's 2 positive and there's 2 negative, so that's going to hopefully help me. Now remember, those can repeat, but so you could have 2 of the same thing, but you can't, so like you could have 1 and 1 twice, because you can have duplicity, and those count as 2 positive, okay? But you will have 2 positive and 2 negative on this one. Now, the next step is to state all possible roots. You do that by using the rational root theorem, which looks at this term and the leading coefficient. Now in this case, the leading coefficient is 1, so that makes it really easy. The only possible roots are plus or minus 5 and plus or minus 1. So that's all the possible roots. This is the answer to B. Okay, those are all the possible roots. Again, I got that by taking the factors of 5, which are just 5 and 1, and dividing them by the factors of the leading coefficient. Well, in this case, the leading coefficient is 1, so they're still just 5 and 1. So that's all my possible roots. So far, pretty easy. Now the next step is to find the roots. This is where we use synthetic division to find the roots. So I want to use either 1 or 5 to try these. I know there's 2 possible positive and 2 negative, so I'm going to try the positive first. And I'm going to try 1 because 1 is easier. So I'm going to try 1 and I'm going to say, okay, here we go. We've got x to the, I'm just going to list the coefficients of x to the 4th. But I want to remember that I've got x to the 4th. That tells me I've got to do this synthetic division twice to get it down to an x squared before I can factor or use quadratic formula. So I'm going to use 1 for the x to the 4th, 3 for the x to the 3rd, minus 6 for the x to the 2nd, minus 3 for the x, plus 5. I'm going to drop the first one. Don't forget to drop that first one. That's 1. Now I'm going to multiply and add all the way across. 1 times 1 is 1. 3 plus 1 is 4. Multiplying 4, adding negative 2, timesing negative 2, adding negative 5, timesing negative 5. That gives me a 0. That's a good thing. That means 1 is one of the roots. I'm going to put the roots over here. So the roots are 1 so far. I know that. Okay, now I know that there's 2 positive and there's probably going to be 2 negative also. I can try either 5 or I can, and I want to use this depressed polynomial. Now, why am I not writing it out at this point? Well, because I have an x to the 4th. This would make this an x to the 3rd. I still can't factor an x to the 3rd as a quadratic. I need to get this down to an x to the 2nd. So this depresses the polynomial by 1 degree when you have a remainder of 0. So notice this would be 1x cubed plus 4x squared minus 2x minus 5. But I can't factor that, so I'm going to have to do synthetic division again. Now, because I know that there are 2 positive and 2 negative, my chances are that one of these is going to work. Now, it doesn't mean that they're all these integer values. Maybe I'll end up with a square root, which is still rational, but it's not going to come out of these. So I still could have some other values, but one of them is still probably going to be plus or minus 5 or plus or minus 1. Now, I'm going to try negative 1 just to see, because again, it's easier to do this by 1 or negative 1, knowing that I have a possible negative root of negative 1. So I'm going to drop down again the 1 times it, negative 1, 4 times negative 1 is, or 4 plus negative 1 is, 3 times it, negative 3, add it, negative 5, negative times a negative is a positive 5. Boom, I got a 0 again, which is sweet. So therefore I know that negative 1 is also a root. So I've got one of the positives and one of the negatives. But now I'm down to an x squared. When you're down to an x squared, I have 1x squared, that's the coefficient, plus 3x, that's the coefficient. Remember, we've depressed it twice because we've done it twice. So it went from 4 to 3. Now I'm down to 2, an x squared term. So plus 3x minus 5. Now, I look to factor this if I can. What multiplies to be 5 and subtracts to be 3? Dang it, none of them. So if it doesn't factor, I need to use quadratic formula because the only factors of 5 are 5 and 1. 5 minus 1 is not 3. So therefore I can't use 5 and 1. So now I have to use quadratic formula. Remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that's in your notes. You're going to need that. That's the quadratic formula. And this is in the form where this is ax squared plus bx plus c. So this is the a value is 1, the b value is 3, and the c value is negative 5. I just plug it into that formula. So the b value being 3, I got to take the opposite of positive 3, which is negative 3. Don't forget to change the sign on that when you write it out here to the side. And then I got plus or minus the square root of b squared. So 3 squared is 9. Minus 4, that's where the 4 came from, is the formula, times a, that's the number in front of the x squared, it's a 1 in this case, times c, negative 5, all over 2 times the a value. Remember, the a value is 1, so that's just over 2. Now I multiply it out. Negative 5 times negative 4 times 1. Negative times a negative is a positive. 5 times 4 is 20. So therefore I get negative 3 plus or minus the square root of 20 plus 9 is 29 all over 2. And I can leave that as my answer. The reason I can leave that as my answer is because the square root of 29 does not factor tree down and reduce. So I want to reduce this as much as I can, but square root of 29 doesn't reduce. So those are my answers. Now you may say, wait, I thought you said there was 2 positives and 2 negatives. I only have 1 positive and negative root out here to the side. Well, I actually have another positive root, which is negative 3 plus square root of 29. And if you think about it, square root of 29 is more than 5 because square root of 25 is 5. So therefore, negative 3 plus 5 is going to make that positive all over 2. Or negative 3 minus square root of 29. That's going to make that negative, obviously, all over 2. So you do have 2 positives, the 1 and the negative 3 plus square root of 29 over 2, and negative 1 and negative 3 minus square root of 29 all over 2. Sorry, that 2 is hard to write there. Okay, so that's how I'm going to do number 10. Fairly easy. Number 9, let's try this one together. Okay, so number 9, I'm thinking about this and I'm saying, all right, I want to check and see, first off, how many positive and negative roots there are. So I'm going to look down here and say, okay, I want to do sign changes. I want to do Descartes' rule of signs. Did it change? No. Did it change? Yes. Did it change? No. Well, this one then only has 1 positive real root. Okay? Because the sign changed only once. Now let's do f of negative x. F of negative x. And we're just looking at the, so remember, if you plug in a negative to an odd, it's going to change. So instead of positive, this will be negative. If you put in a negative and an even, it'll remain the same, plus a negative into a odd is going to change. That's going to be a plus, and the last one will remain negative. Well, that means we got 1 sign change, 0, 1. So therefore we have 2 negative real roots. So this one I have 1 positive and 2 negatives. So that tells me that if I get 1 positive, I can't get any more than that one because there's only 1 possible positive. There are 2 negative real roots, which will help me because I'm thinking, well, I might as well try negative values because I got probably a double the chance of that happening. Now, this is part A again, are these answers. Part B is saying, all right, now that you know that, what are the possible roots that you could try? Well, here I've got to do plus and minus, and I'm doing plus and minus because I have both positive and negative. On some of these up here, you're going to count the sign changes, and you're going to see that there are no sign changes for f of x, meaning there's no positive real roots. Or you're going to take f of negative x, and you'll see no sign changes, which means there's 0 negative real roots. If that's the case, don't try positives if there's 0 positive real roots. Don't try negatives if there's 0 negative real roots. Try only the positives or only the negatives, the opposite thing that you find using Descartes' rule of signs. Okay, now, if we go down, on this one though, we have both positive and negative real roots, so we need to try both. So I'm going to do plus or minus all the factors of 8. So that's 8 and 1. What else multiplies to be 8? 4 and 2. Now, the other values that are possible are these divided by the factors of 4. So, well, what are the factors of, well, if it's 1, all these divided by 1 are just what we have there. But all of them divided by the factors of 4 is also 4. So I need to divide each one of these by 4. I don't have to list them again if they're already listed. So 8 divided by 4, for example, is 2. I've already listed that. But 1 divided by 4, I need to list that. It could be a fourth. 4 divided by 4 is 1. We've already listed that. 2 divided by 4 is a half. I haven't listed that. So it could also be plus or minus a fourth or plus or minus a half. Okay? Now, the last one I want to, the other factor of 4 is 2. So I could divide each of these factors by 2. But think about that. 8 divided by 2 is 4, which I've already listed. 1 divided by 2 is a half, which I've already listed. 4 divided by 2 is 2, which I've already listed. 2 divided by 2 is 1, which I've already listed. So these are all possible values that I could synthetically divide by and maybe get one of them to come out with a remainder of 0. Okay. Now remember, I know there's 1 positive and 2 negatives, so I'm going to try negatives first. And again, I always start with 1 because it's the easiest. So I'm going to try 1. Now this one I'm only going to need to do synthetic division once I find one, because this is to the third power. I'll then have a squared power and I'll be able to factor it or use quadratic formula. So let's synthetically divide by 1. So I'm going to synthetically divide by 1. Okay, I'm going to list these in descending order. 4, 9, negative 30, and negative 8. I'm going to drop down the 4. Remember to drop down that first term, multiply and add all the way across. 1 times 4 is 4. 9 plus 4 is 13. 1 times 13 is 13. 13 minus 30 is negative, I don't know what that is, negative 17, I think. And 1 times negative 17 is negative 17. That one didn't work. So I'm saying, all right, 1 didn't work. Oh, why am I trying a positive? I should be trying a what? A negative. I even said that we have 2 negative roots. So let's try a negative. That might work better. So I'm going to put negative 1, synthetically divide it into 4, 9, negative 30, negative 8. Drop down the 4, times and add all the way across. Negative 4, that's 5. Negative 5, that's negative 35. Nope, that still isn't going to work because that's going to be plus 35. That's not going to be 0. So negative 1 and 1 didn't work. So now I got to say, all right, what else can I try that's negative? Well, I'm going to try probably negative 2 and see if that works. So I'm going to try negative 2. I've got 4, 9, negative 30, negative 8. Dropping down the 4. And sometimes this gets tedious because you got to try a lot of them. So I've got negative 8. That's 1. That's going to be negative 2. That's going to be negative 32. And that's going to be plus 64. That's not going to work either. So I've got, okay, I've tried 1, I've tried 2. Let's try 4, negative 4. So let's try negative 4. So I've got 4, 9, negative 30, negative 8. Drop down the 4. 4 times negative 4 is negative 16. 9 plus negative 16 is negative 7. Negative 20, or negative times negative is a positive 28. Negative 30 plus 28 is negative 2. A negative times a negative is a positive 8. Hey, I got it. Okay, it took me a while to do these, but I do have it now. Because I got a 0 as my remainder there, I now have a depressed polynomial that I can factor, and I have one of my roots. So one of my roots, for sure, on number 9, so I'm going to list this out to the side, my roots, one of them is negative 4, for sure. Okay, my other ones I'm going to get by either factoring 4x squared minus 7x minus 2, or using quadratic formula. Now when I have a number in front of the square, I usually use quadratic formula. I don't use factoring. You could factor with the box method here, and this one's going to factor with the box method. But sometimes it won't factor with the box method, like the previous one, like number 10. So anytime there's a coefficient in front of the square, or I don't think it can be factored, I just use quadratic formula. Quadratic formula isn't that hard anyway. So I'm just going to do that. So I'm doing the opposite of -7, which is 7, plus or minus the square root of, I'm going to do -7 squared, which is 49. Negative times a negative is a positive. Minus 4, that comes from the formula. A, that's that 4, times C, -2, all over 2A, which is 8. Don't forget to do that 2A, which is 2 times the A value, which is 8. Now I left some room under here to work, so that's 4 times 4 is 16. Double 16 is 32. So now I have 32 plus 49. You can do that on your calculator. And you'll get 81. And that makes this really easy. I've got 7 plus or minus the square root of 81. You'll notice 81 is a perfect square. That tells you this would have factored had I factored it, but it's okay if I didn't. All over 8. Now don't forget that that's over 8. So square root of 81 is 9, so I've got 7 plus 9. 7 plus 9, sorry, wait, is that a -7 or a +7? That's a +7, sorry. 7 plus 9 is 16 over 8. 16 over 8 is 2. That's another root. Notice that I had 1 positive and 2 negatives. So far, I have roots of -4, and now I have +2 as another root. Okay, now I'm going to do 7 minus 9, which is -2 divided by 8. Well, -2 divided by 8 is -1/4 as you reduce that. So my last root is -1/4. Now notice when I did my Descartes rule of signs that I had 1 positive real root. Did I end up with 1 positive real root? Yeah, it was the 2. And 2 negative real roots. Did I end up with 2 negative real roots? Yeah, it was the -4 and the -1/4. Okay, so that's how you do, you can review this video if you want, but that's how you do 10 and 9, which are 2 of the harder ones. These are a little bit easier up here, 1 through 8. Those are the ones you need to complete. Good luck. Thanks.